Hello everyone. Welcome to week 3 problem solving session for NPTEL course Getting Started with Competitive Programming. I'm Nikita. I take this session every week on Friday 6 p.m. to 7 p.m. and we solve practice problem from that week's topic. So this week 3's topic is greedy algorithms and we will be solving greedy algorithm problems today. Thank you for joining. So before I start, I will request you to take your pen and papers so that you can try the problems and work out the examples. Also, for the rest of the session, I will have to turn off my video because of some bandwidth issues, and I hope that is fine. As usual, we will first look at the problem statement, then we will work out a few examples. Once we have understood the problem, after that we will try the solving the problem. We'll discuss the different approaches, and once we find that some approach works, we are going to analyze the time complexity of that algorithm. Okay, so that will be the how we are going to do the session. So let's get started. I'll be I hope I'm audible. Can some of you respond saying if I'm audible or not?
Yes, ma'am.
Okay, thanks. Okay. Okay, I hope the problem is visible to you. So I will also be posting this in the chat box for others to see if you want to read it again. Okay, so I will read it out, then I will also give you time to read it again so that you can understand it. So the problem is that at a gadget service center, there are K counters numbered from 1 to K where the staff address complaints of customers. They tried creating a token system so that customers could wait for their turn, but they soon discovered that all of their customers were both impatient and superstitious. Each customer that visits the service center has a strongly preferred counter P based on their lucky number, and because of their impatience, if that counter is already occupied, then the customer simply leaves. Now obviously the owner wants to maximize the total number of customers that get their gadgets fixed, so he allows certain customers so as to achieve this task. You are to help the owner with figuring out an optimal strategy. Given a list of n customers with their arrival, departure time, and the preferred counter, you need to calculate the maximum number of customers that can be accommodated by the service center. Note that we are only interested in the number of customers, and you may assume that each customer brings in equal profit to the shop. Okay, yeah, read if you want. I'm just waiting for 2 minutes so that you can Google it again. Okay. So the input format is that you'll be given an integer t denoting the number of test cases. Yeah, I've posted the problem statement. I will also post the input and the output format. Is it not full? Okay, it's not full, I'm sorry. customer. Okay, it's only the first paragraph. Again, I was not able to. Okay. Yeah, so the problem statement is now in the chat box. So the problem is that there are K service counters and customers are coming, and every customer has a preferred counter, and the customer only wants to use that counter for the gadget service and do not want to use any other counter. And customers also do not want to wait. So if they come and the counter is occupied, then they'll just leave. So, as the owner of that service center, you want to maximize your profit. That is, you want to maximize the number of customers that are served. Okay, and uh, and every counter can only serve only one customer at a time, right? So that is the problem. Now let us look at the input format and do a few examples, and with that the problem statement will become more clear. So the input format is that you will be given t test cases. Each test case has two integers n and k, where n is the number of customers, k is the number of counters, and every n lines contains three integers si, fi, and pi, where si is the start time or the arrival time of customer I, fi is the departure time of customer I, and pi is the preferred counter of the ith customer. So also note that the ith customer wants to occupy the pth counter from si, where si is included, and to fi. Fi is not included. So we assume that it leaves at before fi starts, and any other customer coming at fi time can actually use that customer. That is, the ith customer leaves just before fi, so another customer can occupy that counter from fi onwards. And for every test case, you need to print the maximum number of customers that can be accommodated at the service center. That is for all the counters, and these are the constraints. The number of customers is less than equal to 10 to power 5, number of counters is less than equal to 10 to power 9, si and fi less than equal to 10 to power 9, and pi is definitely less than equal to k. Now I will we'll just go through these examples, and after that let's see if it becomes more clear or not. Okay, yeah. Yeah, so here 2 is the number of test cases, and the first test case has n equal to 3. So I will write n equal to 3 and k equal to 3. Then first customer comes at time 1, departure 3, preferred counter 1, second 4, 6, 2, 7, 10, and 3. So if I plot this, like if I just make a time graph for this, then the first customer is coming at, say this is the timeline, then this first customer is coming at 1, this is 1 and leaving at 3 here. Second is coming at 4, leaving at 6, and third one is coming at 7, leaving at 10. So now, how many customers can be served? That is the question. So for this example, since all of the customers require, our first thing which is easy to see, all of them are actually coming at different times. So it does not actually matter which counter they want to use, although they also want to use different counters, 1, 2 and 3. So since they all want to use different counters, so we will be able to serve all of them. Also they come, so that is the solution actually here. We don't even need to look at these intervals. We can just see that all of them are coming for different counters, and so we can serve all of them. So answer is 3 for this example. Let's work out the second one. So the second one is 4, 2, 10, 100, 100, 200, 2, 150, 500, 2, 200, 300, 2. Yeah, we are solving the problem, and the problem statement is in the chat box. And so now for this example, here we can see that one customer is coming for counter 1, 3 are coming for counter 2, right? So now I want so let's just see here. So there is only one customer for counter 1, so we can definitely serve the first one. Now for these 3 we need to check. One is coming at 100, leaving at 200. So let's say this is 100, leaving at 200. Another one is coming at 150, leaving at 500. And the third one is coming at 200 and leaving at, sorry, 300 is less than 500. Let's say this is 300 and I'll make this here 500. Okay. So then how many customers can we serve at a for how many customers can be served by the counter 2? So if we choose first customer, then we cannot choose the second one because they are overlapping, but we can choose the third one. So if we choose first and third, we can serve 2 customers. If we choose the second customer, then we cannot choose 1 and 3. So then we'll be able to serve only 1. And so the best answer, like optimal answer here, will be 2. So by serving customer 1 and 3 and not the second one, we can serve 2 customers in the counter 2. And the answer for this problem, like for this example, is actually 3. Now let's look at, so this has only these 2, right? Answer is 3 for the first one also and the second one also, because the first one had different counters and the second one we just saw. So now let's make some more examples and then I will ask you to solve that. Let's say there are 4 customers and we will make it like 5 customers, and there are 4 counters, and one is coming at say 1, 3, 2, 3, 4, I'm choosing anything randomly here, and let's just take this. Yeah. So what I want you to just work this out, and then let's see what the answer should be for this. Yeah, yeah, the answer should be 4. Does anybody have any other answer? Or if it is not clear, then also please let me know. Sure, I will explain again with this example. And others, what is NC? Not clear, okay. And for others, did you get answer 4 or something else? Okay, I want everyone to try. If you haven't noted the problem, then do note it now. Okay, so now let's see. So here, let me move the whiteboard. So this is the problem I'm saying. So here we have 5 customers and there are 4 counters. So let me draw it like this, that there are 4 counters, C1, C2, C3 and C4. We have these 4 counters, okay? And every counter can serve only one customer at a time. So if 2 customers are coming at time which are overlapping with each other, then we can choose only one customer out of them. Okay, now we have to choose the customers in a optimized manner such that we can serve the maximum number of customers. Like for example, here we have for counter 1 customers coming at time 1, leaving at 3, coming at 2, then 3, 4 and 5. So here if I choose customer 1 which is coming at time 1, leaving at 3, then I cannot choose customer 2 because they are overlapping. Okay, this coming at 1, 3 and this is 2, 3, so they are overlapping, so they cannot be served at the same time. So we can serve only one of them. So let's say we serve 1, 3 first customer, then and we cannot then serve the second one. Then the third one is coming at time 4, which is greater than the departure time of the first customer. So they are not overlapping, so we can definitely serve this third customer. So counter 1 can serve 2 customers. Now for counter 2 we again have 2 customers coming, 5, 6 and 7, 10, but they are coming at different times, non-overlapping time. One is leaving at 6, other is arriving at 7. So again there is no problem, we can serve both of them, and we can serve 2 at counter 2 also. So in total we can serve here 4 customers, right? Is it clear now? Okay, okay, okay. Now what is the third number in the input? Yeah, third number is the preferred counter. So for the previous example, like which we just saw here, yeah, for the previous example what we had just seen here, it says that when customer 1 is coming at here, this is the input for customer 1, it is coming at time 1, leaving at 3 and the preferred counter is 1. So it wants to only go to counter 1, and if it is not getting the counter 1, then it will leave from there, and we want to maximize the number of customers that are served. So we want to find the maximum number of customers which are not overlapping with each other, right? So that is the problem. Now given such an input, how can we solve this problem? Like I don't want you to tell me the complete solution. Like how will you break down this problem, and what will be the approach? Sort according to arrival and departure time. Sort based on arrival time. Iterate in customers if k free, k count plus plus. Else if k is not free, ni is the arrival greater than occupied departure. K is not free. The greater than equal to count plus plus. Return count. Pick the ones which have minimum interval. Okay. This is fine, but we are also given one more input, right? Counter. So everyone has a different counter preference. So what you're telling me, those are solutions if you were not given any preferred counter, right? If there was only one counter, then you could just use, everyone can go to the same counter. Now if we are given different counters, then we have to break the problem, right? Like what you're saying is telling our solutions. If you have only one counter, all our customers are going to the same counter, but you have to do the same things which you're telling, sort and then do some stuff on that sorted array, that you have to do for every counter, right? According to arrival and then according to departure time. We can deal with each counter independently. We can assign value to each customer equal to number of customers who missed the counter. If we accept it, then we sort the customer reverse order of this value and accept customers in order if there is no conflict. Array of counters, store -1 for not occupied departure time if occupied. Okay. Okay, yeah, so we have to do this independently. So as you guys rightly pointed out, we have to do this independently for every counter. So it actually, the counters are not overlapping with the problems are completely different. So it's like complete different problems for every counter, and we can then use some algorithm to solve it for every counter, and finally we can just aggregate the answer for every counter, the sum of the maximum of value that can be achieved for every counter. That is right. Now let us discuss the approach given. Let's say we will just, for let's say when we don't have, I hope it is clear to everybody that how we are going to, that we are going to for the rest of this solution that I'm going to discuss, I'm going to neglect the third value, which is the preferred counter, because we have to do the same for every counter value which is there in the input, right? And then take the sum for all the counters. I will again repeat this after we have gone through the algorithm once. And now let us just take few examples, and then you all have suggested some approaches. Try to apply those on these examples and see if they work or not. Okay, so example 1 here is, I'm just going to draw some intervals, and so this is the one interval, this is, let's say, second interval, and you can here assume that the length of the interval is actually like the corresponding to the time that the customer stays. So this is example 1. Okay, now I would request you to tell me answers one by one for each of them. That assuming that all of these are start and finish time or arrival and departure time of the customers, and they're coming for counter 1, then how many of the customers can you serve? So for example 1, how many maximum number of customers can be served? 2, that's right. For example 2, look again. For example 2, this is the example 2. Yeah, it is 3, right? Great. And for example 3, yeah, 4 is correct. I want everyone else to once look at it. Four. Others, do you agree? Okay, great. I assume that everyone else has understood this. So now, the first, I'll just take all the, I will just take the intervals that are giving us the answers here. So these are the answers, right? These intervals will be taken. This will be part of our answer. Okay, so now I want you all again to tell me, how will you solve this now? Many of you suggested that sort according to the arrival time. or the departure time and then do something. So, and some of you also suggested that take the interval which is the smallest first and then the next smallest. I think that was the approach suggested. Okay, 1 second. So, I don't know if I'm pronouncing it correctly. Austin, your approach was pick the one that have minimal interval, and I think example one shows that that is not the most optimal. That may not give us the most optimal answer because this interval is smaller than the others. But if we choose this, then we cannot choose the other two, and therefore that is not the optimal one. And many of you have told me to sort them according to the arrival time. Okay, if we sort them according to the arrival time, let's say for example 2, if we sort it according to the arrival time and then pick the one which is coming first, then we would have picked this interval, right? I mean, we would have sorry, I will just unmark. So if we sort according to the arrival time, then in example number 2, we would have picked the interval 1. And if we pick the interval 1, then we cannot pick these two intervals which are overlapping with it. These two ones, we cannot pick them and we can only pick the last interval. Then the answer would have been 2. So that shows that sorting by the arrival time and then taking the intervals and discarding the intervals which are overlapping with it is also not useful to us. If we sort according to the arrival and then according to the departure time, then also I think the example 2 shows that if we sort according to the arrival time first and then according to the departure time, so yeah, it will still not help, I think. So I'm looking for some more answers. Arrival time by departure, arrival time by, okay, are you telling, is this slash means divide, or does it mean or? Sort based on arrival or departure. Yeah, try to work it out once more. So for the last and the last example here is actually showing us that if we greedily pick an interval which is which is overlapping with the least number of intervals, let's for example here this one which I have like highlighted, if we pick this interval first because this is overlapping with only 2 intervals, so if we pick this one, then we cannot pick these 2, and then we can, let's say we pick this one, then we can't pick any of these, and if we pick these, then we can't pick these. So in that manner the answer will be 3 only, and that is the approach when we pick greedily first the interval which is overlapping, which is having the minimum overlaps. So that greedy approach also does not work here. What if we just discard ones that had most overlaps until we got no overlaps? Discard the one which has the most overlaps. Okay, let's see if it works. So first example which has the most overlaps is this one, so we'll discard this. Okay, second example which has the most overlaps is the first one, we'll discard that. Here the most overlap has this, so we discard this one. Then these are same number of overlaps, so we'll discard these here same first, and then these here, and then this, because this is, so this seems to work on this example. I'm not sure if it is optimal or not, which we need to think now. So let's see if we can make a counter example for this. What I'll do in here for now. So here the most which interval has the most overlaps? So here the interval which having more number of overlaps, I'll just write it here. It has one overlap. This is 3. This has 4, 3, and 1. So we discard this one. Then we can discard any one of these, right? So if we discard this one, first we discard the 4 one, then 3 1. Why did we but we could choose, right? Take 1 second, I'm just not clear. What if we discard one side and most overlaps, still we got no overlaps? But how will that work? You discard the one which has the most overlap. Like for example, here I discarded first the 4 one with the 4 overlaps. Then what do I do next? Okay, until you tell me, I will just look at others. Responses: arrival time divided by departure time, and the answer is 3. Okay, yeah, the answer is 3 here. So we don't take 4, but if I understand correctly, it's if I discard this which has 4 overlaps, then I can I see that still these are not, like all of them are not, I still have overlaps. So then I will discard this one which I have marked cross here. Then I will be still left with these 3 which still has one overlapping. Then I again discard this one which has 3 overlap because this is maximum. Then I'll be left with only these 2. But the answer is 3 and what we are getting is 2. Answer is 3 if I choose these 3. So I think that also does not work. Arrival time by departure time, I don't know how will that work. What will it give us? That's a ratio. So if the start time is less and So it's a ratio. I'm not very sure how will it work. Currently I cannot it is imagine how it will work. So most of so the direction is correct. I'll just give a hint now, that instead of sorting according to the arrival times, try to sort them according to the departure time, and then try to see. Be greedy with the time slot. That means if you are going to, I assume you mean to say that time slot size. So if you are going to greedily choose the ones with the smallest size, then this example 1 is a counter for that. You can look again for that. After discarding every most overlapped one, compute overlaps again for remaining. Yeah, so okay, for this one you were saying, when discarded this thing we got here, this one will have one overlap and this one will have two overlaps. So you're saying that this will work here? Yeah, because we will then discard this and not this. Well, this works for this example. We'll again have to see if it works. Mm. Meanwhile, while I try to see if it works or not, I want you to try sorting the array by the departure time and see, like, sort according to departure time, then choose the first interval and discard the intervals which overlap with it, and then choose the next known overlapping interval and go on like this, and see if that works for these examples or not. Okay. To sort by departure time, then example 2 gives 2. How does that give 2? Okay, I'll try to explain this quickly. So example 2, so departure time is indicated by this, like the this is, I'm just using these intervals like these line graphs, right? So this departure time of this interval is less. So this will be at position, this will be 1, this is 2, this is 3, this is 4, right? So we'll pick the 1. Okay, we will pick this one. When we pick this interval, this one is overlapping, so we cannot pick this one. Then we will pick this second one because it is not overlapping, and then we'll pick the last one. So the answer is 3 still. No problem. Has anyone verified that the departure time based sorting algorithm will work for all of them? And are you convinced that it works? I'm actually still trying to make example for Rajesh approach. Okay, if I did anyone verify? If it's not clear, then let me go over it. Can you guys tell me if it is not clear? Okay, yeah, I'll tell every. So example 1, what I suggested was that let us sort the intervals according in the ascending order of the finish time or the departure time. Okay, so if we sort them, then this for the example 1, the highlighted interval will come first, then the second interval, then the third one, right? This is 1, this is 2, this is 3. So once we have sorted them, after that we will pick the first interval, and we'll discard the intervals which are overlapping with it. So we pick the one, we discard this, and 3 is not overlapping, we do not discard it, and in the and then next we pick 3, so the answer is 2. For the second example, when we sort them, we get this order. This one is the first, this is second, this is third, this is fourth. So when we pick them, we are going to first pick 1, then we are going to discard 3, right? And then after that we pick 2, and when we pick 2 we see that there is no overlap, so then we go ahead and pick 4. So the answer is 3 for this one. Now for this one, according to their departure times, we need to just sort them according to their departure times. So this is 1, this is 2, 3, 4, they are same, 5, 6, 7, 8, 9, 10, 11. Okay, this is order. Then when we first pick the first one, here we'll discard all of them, right, because they all are overlapping with it. So then we can pick the fifth one because it is not overlapping, but sixth one is overlapping with the fifth, so we discard this. Then we pick 7 and we discard all of them because they're overlapping, and then we can pick 11. So again the answer, we pick all of these 4 and the answer is 4. For the example number 4, here again I will use eraser and rub these. I will write the sorted order here. So the departure time, minimum departure time, this one, then second is this, third, fourth and fifth. So first we will pick 1, and 1, this will discard this because this is overlapping. Then after that the minimum is 3, we pick this, so we discard 4 because it is overlapping, and then we pick 5. So again we were able to pick 1, 3 and 5, and answer is, that is optimal, answer is 3 here. Sorry, just mistakenly did that. So is it clear now? Okay, thanks. Okay, so yeah, so that's the, so for Rajesh solution I was not able to make the counter example right now. If I'm able to make it, and I will try it after the session, and I will share the feedback according for this on Discord channel. And for now, the approach that I am suggesting, I hope that is clear to everybody. And if it now we are going to relook at the problem, what it is asking, and then we are going to see how we are going to use this, what we just learned, to solve the problem, right? So does anyone have any question? You can also unmute yourself, you don't have to wait to write in the chat box. Sample test case to test my program. For now you can use these ones, and you can, like, currently I don't have, and I will also recommend that all of these examples that I've written here, 1, 2, 3, 4, you make some example, you make some examples from these to test. If you have later I can provide some more examples. Okay, so now let's relook at the problem. So the problem is, instead of me going here and reading that, let's just use the whiteboard, it's easier to understand, I think. Yeah, so we were given that there are n customers, and each customer, for every customer we are given a start time, a finish time, and a preferred counter pi. Okay, so example is 1, 3 and 1. So this means customer 1 is coming at 1, going at 3, preferred counter is 1. Then there could be another customer coming at 2, leaving at 3, preferred counter 1. Another coming at 4, leaving at 5, preferred counter 1. So we currently saw that we can find the maximum number of customers that can be served for any counter by sorting the intervals in the ascending order of the departure time, and then using the algorithm, and then picking one interval and then discarding in the sorted order, discarding the ones which are overlapping with it, and continuing in that manner. Now we have to do this for all the n customers. So second customer can, so the fourth customer can be coming at 5, leaving at 6, but for counter 2. And then one is coming at say 4, leaving at 7 for again for counter number 2, and so on. So we can have that, right? So now what you will do is that once you can do one pass through the input that you have been given, that is this list of customers, and then for every counter you can create this new list, that which customers are for this, like customer 1, 2 and 3 are for coming for counter 1, customer 4 and 5 are coming for counter number 2, and then you apply the algorithm that we just discussed on this list of customers, and then independently on this, and the answer that you will be getting, you have to sum them. Okay, take the summation and that will be your answer. Like for this example, if we apply the algorithm on the first one, we sort them according to the departure times. Already they are sorted, so we'll pick this customer, and then we'll discard the second because they're overlapping, then pick the third. So the answer for the first is 2, and then for the second they're actually overlapping, so we'll first take the customer 4, discard this one, so we get here 1, and then we'll do an addition and we get answer as 3. So that is the entire solution to the problem. Do you have any questions? Is it clear? You can tell me in the chat box if it is clear or not. Okay, and I also want you to now think about the time complexity of this algorithm that we just discussed. The entire okay, first tell me that when you do this, when you're applying, let's say algo, let's name this algo 1, which we had discussed, sort according to departure time, and then pick one interval, discard the others. What is the time complexity of that algorithm? Anyone? Time complexity? Okay, so first we do sorting. So sorting time complexity is n log n, right? And then after that we are only doing one pass over that sorted array, right? So that is order n, and therefore the time complexity is order n log n. That is only for algo 1, which is just discussed. Now for this problem, solving the entire problem also, the complexity is same, that is order n log n, because we have total n customers here, and let's say this n1 customers are coming for counter 1, then this part of the algorithm will take n1 log n1 time. The second one for counter 2 will take n2 log n2 time, and then we will just do. And so if we do the summation of all of that, we get that it is bounded by order n log n. So the time complexity of the algorithm that we just discussed is order n log n. Is it clear? If not, then please let me know. Okay, if others, okay, so so that was, so I wanted to discuss this problem. I wanted to discuss one more, but I think there is no time left for that. But and for the implementation, I will put that on the GitHub and I will share it with you. Also, this I will, this problem, you can, if you want to read, you can read the problem and the solution in the Kleinberg and Tardos book, chapter 4, greedy algorithms. So this is actually the first greedy algorithm problem that they discuss in that chapter, and followed by some more interesting problems. So you can read that, and I'm sure that your understanding will improve after reading the book. Okay, so then we can end the session for now, and I will be posting the problem, solution, and the recorded lecture on Discord channel soon. Algorithm design by Kleinberg and Tardos. Yeah, so this is the book. So chapter number 4, greedy algorithms. This is the first problem that we discussed today, interval scheduling. So do take a look at that, and I'm sure that you will understand it better after that. Okay, thank you for joining. I will post everything, and I will also notify you on Discord channel. Thanks again. If you have any questions, then I'm here. You can ask me. If you do not have any question, then you can leave the meeting. Thank you. Yeah, thanks.